Today we're going to start talking about composite functions. Before we talk about composites, we're going to talk about combination functions, which are when you can add, subtract, multiply, and divide functions. And it gives you a new function. So we're going to do this. We kind of, I think, talked about this at the very, very beginning of the year in the fundamental skills unit. But we're going to talk about the combination function, and we're going to find the domain of the new function, which is bringing back the domain rules that we did also in the beginning of the year. All right, on example 1, it says let f of x equal 5x minus 8 and g of x be 7 minus 2x squared. And I want to figure out what f minus g of x is. So the first thing that I want to note is this parentheses x. All right, this guy right here is not a multiply. All right, it does not mean to multiply x, and that is the biggest thing that people do, is they multiply by x. Do not do that. This means of x. It just is notation. It's saying that f and g are made up of x's. So you know when you have like f of x and you have the parentheses x, all right, same thing. That's what this is. It's f minus g of x. So it's just notation. It doesn't mean to multiply. All right. So now I want to actually work out what f minus g is. So I'm going to start off with my f function, which is 5x minus 8 minus, and then my g function, which is 7 minus 2x squared. I'm going to distribute my negative, negative 7 plus 2x squared, and then nothing to distribute with the 5x minus 8, so I'm just going to drop that down. Okay, so from here I have all my terms, and I'm going to combine like terms. Can you combine anything with the 2x squared? Nope. What about with the 5x? Nope. And what about the negative 8 and the negative 7? Yes, negative 15. And that's your answer. Okay, hop over to example 2. All right, so same thing on example 2. This does not mean to multiply this of x here. Oops, spelled multiplying wrong. All right, not multiplication. It means of x. All right, it is notation, f times g of x. We are going to multiply the f and the g together, though. So I'm going to zoom out so I can see my f and my g. And then I'll zoom back in. All right, so f is going to be 5x minus 8. G is going to be 7 minus 2x squared. And then we're going to multiply that, so we have to FOIL everything. So 5x times 7 is going to be 35x. 5x times negative 2x squared. Negative 10x cubed, good. And then we got to distribute the negative 8. So negative 8 times 7, negative 56. And negative 8 times negative 2x squared, positive 16x squared. All right, and then you're going to look. Do you have any like terms? No, so this is your answer. You will generally see it in descending order, but you don't have to put it in descending order if you don't want to. My OCD kind of like hurts me a little bit not having it in descending order. But if you boxed this as your answer, I would have given you full credit. Okay, so now let's kind of talk about the domain of these functions. So f we're making now as x cubed, and g is going to be the square root of x plus 1. All right, so my first operation here is f plus g. So I'm going to take x cubed, and I'm going to add it to the square root of x plus 1. Can you add x cubed plus the square root of x plus 1? No. There's nothing I can do here. This would be as much as I could simplify. So now let's talk about the domain. So from our domain rules from the beginning of the year, we are looking for fractions and square roots. What do we have on this one? Square roots. What's the rule for square roots? Greater than or equal to 0. And what has to be greater than or equal to 0? The inside, yeah, which is going to be the x plus 1. So just the inside, the x plus 1. So I only care about the inside of the square root for my domain restriction. So my domain is going to be x has to be greater than or equal to -1. All right, so now let's do the same thing, but instead of adding, let's subtract them. So it's going to be x cubed minus the cube root of x plus 1. Now, if I'm just subtracting, can I simplify that at all? Nope, still going to be the same thing. Will the subtraction sign change the domain rule at all? No, because the domain rule only counts for what's inside the square root. I do not care about what's happening outside, just the inside. So the domain is still going to be x has to be greater than or equal to -1. Y'all know why we have to set the inside greater than or equal to 0, right? Because what happens if you get negatives? Imaginary, yep. So if you get negatives inside your square root, you get imaginary numbers, and we don't want those. But also, Bryson's right, it's because it says it on the poster. So yes, make sure you follow the rules. All right, now we're going to be multiplying. So x cubed times by the square root of x plus 1. Can you distribute the x cubed into your square root? No, you cannot, because this square root is its own little house, and x cubed can't go in the house because it's not its house. That makes sense. You cannot distribute. All right, these are not parentheses. The square root does not act as parentheses. So this has to stay on the outside, so this is as far as you could go. Will this guy being multiplied affect your domain rule at all? No, because it's not changing the inside, and the inside is all I care about. So x still has to be greater than or equal to -1. All right, and then my last guy is dividing. So x cubed divided by the square root of x plus 1. Can you simplify this at all? Nope, you cannot. So this is as far as I can go for the operation. Will this guy affect my domain rules? Yes, because what do I have now that I have to keep into account? Cannot equal 0. It's a fraction. So fractions are also going to give you another domain rule. So it is true the bottom has to be greater than or equal to 0. Or not the bottom, I'm sorry. Inside the square root has to be greater than or equal to 0. But the whole bottom cannot equal 0. Does that make sense? So what we're going to do is we're just going to take off the or equal to bar, because it can't equal 0, because it's in the bottom of the fraction and you cannot divide by 0. So we're going to say x plus 1 has to be greater than 0, not or equal to, because it's in the bottom. So x has to be greater than -1. Bless you. Does that make sense? All right, it can't equal because it can't be 0 on the bottom. It still has to be greater than 0 because you can't get negatives on the inside. All right. Now we get to talk about composites. So a composite function is when you have functions in functions. And it is represented with an open circle. So that open circle right here, do you see it right here? That is not a multiplication sign. So once again, not multiplying. That means composite. Uh-oh, what happened? All right, so this little open circle is another way of writing this notation right here. So let's look at our steps. All right, step 1 is to rewrite. So I don't like the open circle. All right, it's kind of confusing. So I want to rewrite this guy as this notation. And the best way to do that is instead of having your open circle, we're going to throw up a parentheses around whatever that second letter is. So instead of the open circle, just put it in parentheses. And then you can clearly see that my inside function is g, and my outside function is f. I'll see what I'm talking about? Okay, so first we're going to rewrite it. Then we are going to replace whatever the inside function is. So whatever it tells me g of x is, I'm going to replace that. And then you're going to substitute that inside function into every single x value in the outside function. If that step doesn't make sense, it will when we do an example. And simplify. All right. So down here, I've got a new f, g, and h. So on example 7, the first thing I'm going to do is rewrite that open circle as a parentheses. So then I can tell that my inside function is which one? G of x. And what does it tell me that g of x is? What does g of x equal? 1 over x minus 2. So I'm going to replace g with whatever g is. G is 1 over x minus 2. Getting that from g of x equaling right there. All right, so now I have this guy. So I'm done with g. G is not my problem anymore. I have 1 over x minus 2, and I have f on the outside. Does that make sense? So now I'm looking at the f function. And so what we're going to do is for every single x value, you are going to replace x with 1 over x minus 2. All right, so you know in basketball and in football, and I'm sure other sports, soccer, what have you, and you have substitutes, right? And so someone would come out and your sub would go in, right? Same thing with this. Your x is coming out of the game. 1 over x minus 2 is going into the x spot. All right, so these x's are not there anymore. They're coming out. This guy goes in that spot. Does that make sense? Okay, so we're going to rewrite it. So we've got 1 over x minus 2. That's going in this spot right here. All right, I still have the squared. I still have the plus 2. This guy's coming out. And in place of him, I'm going to put 1 over x minus 2. And then I still have the minus 1. All right, setting it up, is that okay? All right, we're not going to simplify it a whole lot. I'm going to go ahead and do 1 squared. What's 1 squared? 1. So I can rewrite that as 1. The x minus 2 squared I'm going to leave as x minus 2 squared. And then over here, when you multiply the 2, are you going to multiply the top, the bottom, or both? The top. Only the top. All right, don't multiply the bottom because it's an understood 1 on the bottom. So just the top. So plus 2, the bottom is going to stay x minus 2, and the minus 1 is still hanging out there. And that's my composite. All right, you ready to try another one? So let's go down to 8. This one right here. All right, first thing I'm going to do is I'm going to throw up parentheses in place of that open circle. So what is my inside function going to be? f of x. Which is that guy right there. So I'm going to write g of, and then f of x, which is x squared plus 2x minus 1. All right, I've taken care of the f now. I'm done with f. I don't care about f. I'm not looking at f anymore. Now I'm going to look at g. So in the g function, which is the blue one right there, in place of the x, I'm going to put x squared plus 2x minus 1. All right, it's still in a fraction. The one's on top, the minus 2's on bottom. All of that stays. The x I pull out, this goes in. Does that make sense? All right, so it's going to be 1 over x squared plus 2x minus 1 and then minus 2. All right, so the 1 was from the original. The fraction is from the original. The minus 2 is from the original. The x squared plus 2x minus 1 is what's getting replaced for the x. Logan, do you have a question?
Yeah, Chase was coming, but I don't know where he is.
Okay, I'll be done in 5 minutes, I think, and then I can help y'all with the Revenge of the Tables if you need. It does work. Okay, so down here, what things can you combine? Yeah. You could, but you don't need to because we just wanted to simplify. But it is practicable. Okay. Yes, just when you multiply and combine everything, that's simplified. All right, let's try 9. So 9, I'm going to throw up parentheses. H of x is going to be the square root of 3x. And so this guy is getting plugged in to the f for all of my x's. So I'm going to start with the square root of 3x. Then I have a squared plus 2. In place of the x, I'm going to put the square root of 3x. And then I have minus 1 from the original. So all of the green stuff is coming from the original f function, and then the orange stuff is what I'm replacing x with. Does that make sense? Okay, what simplifies?
3x,
Yeah, this guy right here, those will cancel. And so I just get 3x plus 2 square root of 3x minus 1. All right, and then my last one here, parentheses, around instead of the open circle. F of x is going to be x squared plus 2x minus 1. And now we are going to put this f of x into the h function. So the h function, what does it start off with? A square root and then the 3. And then in place of x, we're not going to write x. We're going to put x squared plus 2x minus 1. And what could I do to simplify that? Yeah, multiply everything by 3. All right, composite functions. Are we good with that? Sweet. All right, down here on the bottom. It says for each function h of x, we want to figure out what f and g are if f of g of x, if h of x equals f of g of x. So we want to come up with the inside and the outside function. So the inside function is g of x because it's on the inside. The outside function is f of x because it's on the outside. So when you're looking at these guys, look for something like inside parentheses, inside square roots, things like that. So on A, I have inside my parentheses x plus 3. So x plus 3 is my inside function. When you go backwards, right? Because this is the composite function here, and I want to kind of like break it up. When I go backwards, I'm taking the x plus 3 sub out, and I'm putting the x back in. Does that make sense? So your outside function is just going to be x squared. All right, so on B, I'm going to say the inside here is the bottom of the fraction, the x minus 5. So what would the outside function be? 1 over x. And then on C, what would the inside function be? X plus 2. And so then the outside function would be square root of x. And then the last one, what would the inside function be? X minus 2. And the outside function would be?
X squared.
Yes. All right, one other thing. Flip it over. All right, we got some graphs. So we have a graph of F. We've got the graph of G. And I want to figure out what F plus G of X is going to be. All right, so when I add these two functions up, is there anything I can combine with the x squared?
No.
Nope. What about with the x? Nope. What about with the negative 1? Yes, so that's going to become negative 4. All right, now we're going to graph them. So let's start with the f function. What does x squared minus 1 look like? A parabola, and it got shifted? Down 1. Okay. For g of x, x minus 3 looks like a what? A line. Yep, and the y-intercept is negative 3. All right, x squared plus x minus 4 looks like what? A parabola. All right, it's in standard form, which is the least helpful form. Now, you can do this two ways. One, you can plug in the calculator and get the graph. All right, I'm fine with that. The other way to do it by hand is to add up the f and the g from the graphs. So, for example, let's start with negative 1. What is the y value at negative 1 on the red graph? 0. What's the y value here? Negative 4. So 0 and negative 4. So what's 0 plus negative 4? Negative 4. Okay, now the next point. What's the y value here? On the red graph. Negative 1. What's the y value at 0 on the blue graph? Negative 3. So what's negative 1 plus negative 3? Also negative 4. And then let's do this next point that we know. So on the red graph, what's this y value? 0. What's this y value? Negative 2. What's 0 plus negative 2? Negative 2. All right, so I know it's not a lot of points, but it's enough because what do I know the shape of this graph is? A parabola. All right. It's a rough sketch, but it's enough. All right, questions? Awesome.